Okay, everyone, we're gonna get started now. It's like 4:09, 4:10. Um, yeah, today we're gonna be going over Pandas. Think of it like Excel for Python, but on steroids. It's really useful. Everyone uses it. Also, if you don't know me, I'm Will. I was here the first time. I haven't come since because I have a class at this time. So, yeah, I'm like the dad that came back with the milk. So, anyways, let's get started. Um, Hold up. Yeah, as a reminder, lectures are recorded. If you miss something, want to check it out, hit up our YouTube channel. Lecture should be there, except for lecture 12, I think. Lecture 12 is the only one that's not. Um, so little like agenda for today. As usual, we'll go through some announcements. We'll have like a little warm up so you guys are ready for coding. Then we'll basically demo pandas, all the fun stuff that we can do with it. So, and then at the end, a lecture engagement for you guys to fill out, just to make sure you guys are paying attention. So yeah. So a couple announcements. Homework 7 is due this Wednesday, and then homework 8 was released today. Um, so I don't know. Get started on that if you will. Um, Homework number 8 is due next Wednesday, so you guys have a week for that. Um, and then the check-in is due this Wednesday, and also your project proposals are due next Wednesday. So if you haven't started on that, would recommend starting soon. Because project proposals are first, the final projects are really cool, and they're fun. So don't push it off to the last minute because then you fall further and further behind, and it's kind of tough to catch back up. So yeah. So let's start off with a little warm up. We're gonna basically review. You guys did NumPy last class, right? Yeah. So just make sure you guys remember a little bit from that. Because both NumPy and Pandas are like sort of interchangeable, not interchangeable. They work well with each other. So hopefully you remember that. So I'll give you guys like uh 3 to 3-ish minutes, 5 minutes. I don't know, however long. Until people stop writing, I guess. Just answer these questions on a piece of paper. Don't use your laptop, otherwise kind of defeats the purpose. And feel free to talk to each other. So yeah. And then raise your hand if you have any questions. So yeah. Okay, who needs more time on the questions? Cool. Okay. Can somebody tell me what the first question does? Go ahead.
There's 10 points evenly spaced between 10 and 100.
Yes. So can you list them out?
10, 9, 28, 37, all around.
It almost. It does because they're spaced by 10, it's 10, 20, 30, 40. It doesn't stop at 9. So yeah. Cool. Good job though. And then does someone want to answer both 2 and 3 because they're very similar in the back?
Just use
Yeah. Which one is which?
so one for would be you produce vertical subplots, and then for one would be
I think that's correct. Maybe we'll check on the next slide in a sec. And then who could tell me how to make a legend? Anybody? Oh, you guys didn't go over that? Okay, sorry, I didn't watch the last lecture. My bad. So yeah, you make a legend using plt.legend. It's yeah, that one's Googleable, I guess. So yeah, it's easier than it sounds. Okay. And then this one's I'm not gonna have you like look it up or like tell me, so I'll just show you just so you guys can check. So yeah, basically, these are the answers. Yeah, if, I'll give you guys a second to look at them and understand. I'll go over five, I guess. To make what was it? It was a plot of tangent from 0 to 4 pi. Yeah, basically you import matplotlib, and then you're using linspace to basically make it look continuous. You say like I want like 1,000 points. So it's not truly continuous, but it looks continuous on the graph. And then use NumPy to create the tangent function, and then you feed all the x values into it, and then you make a plot. Does that make sense to everyone? I know it's kind of like hand wavy, but yeah. Okay, cool. Let's move on. So now we're gonna actually move into the demo for pandas. So let me go ahead and switch to where is it? My yes, this. So pandas is a library just like NumPy. So just like NumPy, like you guys do like import NumPy as NP, right? So can someone guess for me, like how would you import pandas? Just as a guess.
Oh.
Yeah, import pandas and then yeah, correct. That's right. So import pandas as and the convention is to call it PD because it's kind of annoying to type pandas every single time. So that's why we use PD. So yeah. Oh, by the way, if you guys didn't know, B course is down. So on Ed, it's back up. Cool. Awesome. That will be posted later. For right now, the this demo notebook is posted on Ed, and then there's also a CSV file you guys need to download on Ed as well if you want to follow along with lecture. So if you haven't done that already, just hop on Ed and you'll find a staff announcement. So yeah. Don't worry about the CSV file until a little bit later, but yeah. So next part is to actually like create a pandas series. So within the pandas library, there's something called a series. Think of it basically like it's basically like a list. So here, let's call it, I don't know, panda. Panda is panda series, and then like we can make basically create it from an array of numbers. So I could put like, I don't know, 14, 26, 42, 1,065, and then that creates a panda series. So then when we display it, it'll look like this. So essentially, it will display like the index of whatever value is there, and then the actual value itself, and then it'll tell you the data type of what's contained in the series. Um, yeah, actually, yeah, that's correct. I don't know. Do you know if you can add like mixed data values in it? Okay, so okay, we can try it. Let's test it. I actually don't know. So if I make this a string, um, still works. And I guess it reverts to object because a string is an object. So yeah, you guys can mix and match like data types. I can put like a Boolean here, so like false, and then it'll just say object, I guess. But if it's all like one thing, then it'll say what it is. So yeah, that's a series. And then just like a NumPy list or NumPy array. Wait, can you do mean and max in NumPy? I forgot. Yeah, okay, yeah, you can do mean and max in NumPy. So basically the same thing for a series. We can take the mean of this by doing panda.mean. So that gives you the average value of all the numbers in the series. You can also find the max. So panda.max, same thing. The biggest one is 1065, obviously. And then we take the smallest value, panda.min, I think it should be 14. Yeah, 14. So yeah, hopefully that's like pretty intuitive because you guys, oh, is anything confusing? Any questions about this? Am I going too fast? Good. Okay. Yeah, so it's basically like a NumPy array, but the series object is used to construct the next thing we're going to talk about, which is, should I even show the slide? All right, we're talking about a pandas data frame next. So that's essentially what a pandas data frame is. I told you before it was like Excel for Python on steroids. So a series object creates like a table, basically. I'll just show you. I'll just show you. Sorry, it's a little all over the place. But yeah, so just like a series is created from an array or like a list, a data frame is created from a dictionary. So yeah, you guys know what dictionaries are, right? Yeah, okay, cool. So wait, Pranati, do you have like I don't have like the other the actual like demo list. Sorry. Sorry, thank you. Yeah, I don't remember what I'm supposed to put here, so give me a sec.
Oh, yes, that's in Discord, didn't you?
Did I send it to you on Discord?
Oh, but it's also on the drive.
Yeah, it's on the drive. Like the lecture version is like I just did that like last night. So
Okay. Oh, like what data they input?
yeah, like I just want to make sure it's consistent with
Okay.
like the
The
demo
rest
so
of
they
it.
don't get confused. Like I also want to put random stuff in
Yeah,
it. So
you could in theory put random.
yeah, I could, but like make it confusing and I'll forget what everything's supposed to be. That's okay. While you're waiting, download the CSV file.
Yes. Gonna open.
That's fine.
Computer's so slow. I'm running like a
Death, taxes, and chronically slow Campbell Wi-Fi.
actually. I'm running like a really Python.
Oh, I see. So it's like the memory's bad. Okay. It's okay. Anyways, okay. All right, let's get back on track. So yeah, you guys remember dictionaries? There's essentially a key, like a list of basically key value pairs. So for example, we can make a list of people's names and how old they are and what city they're from. We'll start with that. So for example, we can make the first key name and then we can put names in it. Somebody shout out a name. Sarah, okay? Give me another one. Jose. Okay, last one. Something fun. Ashmore? Macklemore. Macklemore. Like the rapper?
Yes.
Very cool. Okay. Macklemore. I like Macklemore. Okay. Cool. And then let's give these people ages. So we'll name this key an age. How old is Sarah? 5? Okay. How old is Jose? 83. Okay, damn. And how old is wait, actually, let's look up Macklemore's age. He's 42. You got that on lock? Damn. Oh, he's right. Wow. Somebody's a fan. Okay, so Macklemore is 42. Perfect. Okay. And then where are they from? I think I remember Macklemore's from, did it say Kent, Washington? Is that Washington? Yeah, it's Washington. Okay, he's from Washington. We'll say Kent. Because it's city. We'll put the cities down. Where's Sarah from? We'll say Rancho Cucamonga. Okay, I like that. Rancho Cucamonga. Where's Jose from? Somewhere, let's find somewhere like obscure. Obscure cities. Oh, this is like literally a book. Um, what's up?
I think there's a city called like the F word.
Oh, okay. I don't know if I can like put that on there. So Weed? Is that a real place? Okay, fine, we'll call it Weed. And then Macklemore's from Kent, Washington. So yeah, this is yeah, so thanks for participating. This is a dictionary. And then these can be used to basically create a pandas data frame. And then I'll show you in a sec, but if we call just like series where it's called like panda.series, if we call pd.dataframe on data, then we get something very cool. It's a table. Like I said, Excel for Python on steroids. So it's a table where the keys are the columns and all the values in them are like the associated values for the table. So yeah. And then sometimes you want to know like all the columns in a data frame. So you can print the keys. So like print what do we call we didn't call it anything. Let's call it Macklemore, I guess. Macklemore is that, and then let's display it. Anyways, so then we can print the keys of Macklemore. So it'll give you basically like the name, the age, the city, all the columns of this table, and the data type. We can also print the values of a specific column. So I'll have you guys guess this one. How do you think we would access the values of one of the columns? What's up? Row column indexing. That's a good guess. That's for like one specific value. But like what if I want like all the values in city? Macklemore.values. That will do something a little different, I think. Good guess though. Yeah, it doesn't make sense, I don't think. Or it doesn't understand. But yeah, essentially it's like indexing a list. So you guys know how if you have like a list, so if like I make a list called list is or no, not list one is equal to like 1, 2, 3, 4. And I called like list 0. This gives me like the 0th index, or wait, list 1, 0, sorry. List 1, 0. Let's rerun that. Okay. Yeah, list 1, 0 will give me like the first element. So it's sort of the same where you index the column name. So like if I did Macklemore name, it would give me all the values in name as a series, as a panda series. So like think of each one of these like columns as like a panda series, like that we just covered. So yeah. So if I wanted the ages, then I'd do Macklemore age. And then if I want the cities, I do Macklemore city. So yeah. Fantastic selection of names, you guys, by the way. Yeah. So wait, this is not supposed to be there like that. Okay, never mind. That's okay. Well, so then if we want to wait, did I already do this or did I mess up? Oh, never mind. Ignore this. Um, okay. Oh, I messed this up. Sorry, this is not like I put like little bold titles for what I want to do for each thing, but I just ignored that completely. So just forget about that. Okay. Anyways, if we want to print multiple columns, so let's see, if I wanted to print both name and age, like as one thing, can anyone guess how we would do that based on how we just accessed one column?
The comma and the next.
Yeah.
column.
Yeah, pretty much. So I do Macklemore. It's kind of important. You guys should put another set of brackets. It's like a list of the strings or the names of the columns that you want to be selected. I forget this a lot and then it gets confused, so don't forget it. So if I want to do both the name and the age, then we see that it's basically like a segment of our data frame. So we can see that all the names, all the ages, all that stuff. Cool. What else did okay, print a row. Let's figure out how to get a row. So like what if I wanted all of Sarah's information? So I don't want to know all the names or all the ages. I just want to know specifically for Sarah. like what like that like her information. There's a function called loc. It's basically means df dot sorry, not df. Loc is like location. So if I did Macklemore dot loc, and then loc is by index. So like you know how in a list, oh it's not? Is it oh no, yeah, you're right. Sorry. iloc is something different. Loc is by the actual names of all the columns. So so if I did dot loc Sarah, that's wrong because that's yeah, my bad. Yeah, that's not correct. Sorry, this is 0. Yeah, this I swear I know pandas. Yeah, so the the indices like 0, 1, 2, it corresponds to like the different so you can see there's like a 0, 1, 2 here. It corresponds to like the different rows of the data frame. So oh yeah, yeah,
Okay.
go ahead.
So when we're talking about dot lock or loc, I guess, I don't know, I call it dot lock and dot iloc. So those are two ways that, see how here we just like kind of picked columns by column names. Sometimes you want to pick rows, sometimes you want to be a little bit more explicit about what exactly you're finding. So that's when you can use dot lock and dot iloc. Dot lock starts with an L, it is label based. So you can think of that as like the name of your row or column. And then dot iloc is index based. So that's going to be like numbers. However, look at this data frame. You see that the rows' names are also numbers? It's a little confusing. So for using dot lock on the rows like we just did, you would still say dot or put in 0 because 0 is the named row. That is the 0th row. So both the label or the name and the index is 0 for that row. But for the columns, it's different. The 0th column, index 0, but the label would be name. Does that make sense? Okay, then you can continue.
Thank you. Yeah, I know. I completely forgot about that. So thank you, Pranati. Yeah. So yeah, what she said. So yeah, that's how you access like the elements of a row. And then another thing that we might want to do with the data frame is to like filter specific columns. So like for example, if I wanted only the people who are older than what are their ages? Let's say you have to be older than 5, so you have to be like an adult, right? Let's say yeah, that's what we want, right? So what we'd do is we would say, okay, within Macklemore, I want to have the columns of Macklemore, so or column of Macklemore that corresponds to age. So Macklemore age, oops, age, and then I want those values to be greater than 5. So if you do that, then you see that only Jose and Macklemore are older than 5, and our column is now filtered. Or not column, data frame is now filtered. So yeah, that's essentially how you like would filter based on columns. And then you could also do it like if you want like, oh, I only want the people who live in what are in Rancho Cucamonga. Yeah, Rancho Cucamonga. I would say, or can someone guess for me? Like, how would I find all the people that live in Rancho Cucamonga in this data frame? Go ahead.
Macklemore, bracket city, equals, Cucamonga, and district.
Exactly. So say equals Rancho Cucamonga. Perfect. And then we find that Sarah, who's 5, is the only person that lives in Rancho Cucamonga in this data frame. So yeah. Perfect. And then let's say that, oh, I realized that my data frame is actually wrong. Everyone's actually a year older than they actually are. So Sarah's not 5, she's actually 6. And Jose is not 83, he's 84. Or like a time has passed, there's an outdated data frame, we want to update it. So the way we would do that is we would say that we're going to reassign the column of Macklemore, which is, or the age column of Macklemore, to be all the values in the age column of Macklemore plus 1. So essentially what this does is that it now changes, sorry, I should have chosen a different name. It's kind of confusing to say Macklemore all over again. But anyways, Macklemore, the data frame, will now have everyone's ages updated by 1. So like the year is now 2026. Everyone is older by a year. Yeah. that's essentially how you would alter a column or update values in a column for a data frame. And then let's say that we want to create a new column within our data frame. Like, what if we want to know who's a senior citizen? So, like, I think the cutoff age is like 65, right? Something like that. For example, we could add a new column that says like, okay, we want to create a new column in Macklemore called senior citizen, question mark. And then we would set that equal to if a person in Macklemore or someone's age within the Macklemore data frame is greater than 65, I think. Yes. So then now when we look at Macklemore, the data frame, by the way, we see that Sarah is obviously not a senior citizen because she's not even an adult yet. And then, Macklemore is not a senior citizen yet. Another like, what, 23 years? Yeah. But Jose is a senior citizen because he's 84. And we should cherish our seniors. So, yeah. So, anyways, that is sort of like a quick overview of all the stuff you can do with the Pandas data frame. Very simple methods and everything, but really, really useful when working with like a lot of data. So Pandas is like your best friend if you work with a lot of table data. So yeah. Do we have anything like, oh wait, this is like, oh, okay, this is you, Pranati.
Thank you, Will. So what we just looked at, like Will said, was like straightforward how to, number one, create a Pandas data frame and how to do a couple like simple operations with it. This is by no means like the limit to the power of Pandas. It's a very, there's so much more that you can do. It's great with sorting. It's great to work with NumPy. If you remember, like last week, I showed you a bunch of those NumPy functions. NumPy is extremely compatible with Pandas, so you could just take any of these series and just use NumPy functions on it, which is wonderful. There's also a similar documentation page for Pandas. I would recommend you guys start getting familiar with that because it will be useful. But an example we just showed you, we had a very small data frame with a couple of values that we made ourselves. However, a lot of times when you are working with data, as you will be for the final project of this class, you will be working with existing data. Obviously, there are many circumstances where you collect your own, but for the purpose of data analytics, you usually have some kind of data source from some kind of scientific instrument that you are using that you are not collecting. So what's more important to know how to do is how to pull that data into Python or into your notebook setup and use it with Pandas. And it is thankfully very simple. So if you haven't already, please take a second to download the CSV file that I put on Ed and make sure it's in the same directory or same place as your lecture notebook if you're following along. Do you have it downloaded?
The CSV, yeah.
Yeah.
It should be
Okay. If you've done that already, give me a thumbs up. If you guys need a second, we can take a second. Okay, I feel like people mostly have it downloaded, but I'll still give people like a minute to do that if need be. Okay. I'm also just gonna import NumPy because I might want to do shenanigans with it. But that should be something everyone's familiar with by this point. Okay. Once you have your CSV in the same folder or same directory as your current working directory that you're using your Pandas notebook in, we're gonna import that CSV file into Jupyter. So firstly, a CSV file. CSV is like your typical Excel spreadsheet. It stands for comma separated values. If you've ever looked at a CSV file in its like raw form, so like not as like a .xlcs or a .csv, the way that the values are separated to tell your computer like this is a column, this is a value, is they're all separated by commas and spaces. Hence .csv stands for comma separated values or something like that. And different files are separated by different types of, we call them delimiters. Sometimes it's a space, sometimes it's a comma, sometimes it's other things. Sometimes it's like an enter, so like a new line character. So text files are done differently, CSV files are done differently. There's also a lot more like complicated other types of files like .nc and this and that have like specific delimiters, and you might have to know that stuff when you're working with those more complicated file types. A lot of times, unfortunately, real world data will come in those file types, but thankfully the internet is a vast place with many resources. But in general, if you know the file type by its extension, you can figure out how to load it in. And Pandas is pretty like flexible. You should be able to do most types of imports with Pandas as long as it's tabular data. So the way that you load something in, first we're going to call it DF, which stands for data frame because we're loading in data into a data frame. Let me actually put this before. So I'm going to say df equals pd because I'm using a pandas function dot read CSV. So here pandas actually is a specific inbuilt function just to read CSV files. You can also find like ways to read in text files and other types of files with different read functions and using different delimiters like I just talked about. And here we just put in our file name or file path. In our case, our .csv file is in the same directory that our notebook's in. So we don't have to worry about it. They're in the same folder. They can see each other. They know what's going on. So you can just type in students.csv, which is the name of the file. However, let's say you had your notebook and then you had a folder, and in that folder you had a bunch of different CSV files. The way you would do that is, if you guys remember from all of the lectures where we were telling you how to use your terminal, you basically put in a path. So you'll do like your folder name, whatever that is, slash whatever, go, so on and so forth. So now you know where it is useful to know how to find things, the way your computer finds things. But for now, let's keep it simple. We're just going to do that. And then I'm just going to say df, just so it outputs. Okay, cool. I have a still pretty small, but a little bit bigger than data frame that we just worked with. And it is my students.csv data frame. So in this case, our first task as listed is to just look at the first three values. Sometimes when you have a super, super large data frame, like let's say you have like 3,000 rows and like 50 columns, very, very common to have data like that. What'll happen is the display will like truncate. So you'll see like the first few rows and then you'll see like ... because it can't display everything. But let's say that you want to force Pandas to show you a certain number of rows. There's a really easy shortcut to do that called df.head. And then all you do is put in the specific number of rows you want to see. So if I do this, sorry, I'm so used to like my Windows shortcuts. Okay. This gives me the first three rows. Simple, easy. It's just a display function. So it's not actually like changing the data frame at all. Yeah. It does truncate horizontally as well. But sometimes, actually, I think you might be able to scroll through all the columns. I don't know.
Sometimes if it's too long, it'll also go dot dot dot. But like I think in the Python notebooks, you can like see.
You can usually see all the columns, like because you can just like interactively scroll. But if you want to see some specific columns, number one, you could always open the original source file, or number two, you could always, like we looked at earlier. Wait, did we look at this earlier where we did all the column names and all the? Did we do that?
Yes.
Okay, where we looked at all the column names, you can always look at all the column names like that and then access whatever specific columns you're interested in by using indexing. But yeah, this is just a shortcut for rows. Maybe there's one for columns too. I don't really know. Perhaps that's a good question to ask the interweb. Okay, so I'm gonna give you guys a second. So similarly to what we talked about a little earlier when Will was demoing, I want you guys to take a second to try to number one, compute the average grade of these students. And then number two, just compute what the higher grades. And we're going to say a high grade is any grade that's above an 85. So take a second to work on just those two examples, and then we will come back together. Okay. And feel free to chit chat, do whatever you need.
Raise your hand if you have questions.
Yes, please. Oh, I also will say a quick thing in general, because I know that this can mess people up. if you have a notebook, please refrain from naming it the name of a package. So let's say you're working on pandas, don't name your notebook pandas.ipynb because it'll like yell at you. It'll be like, what you're basically doing is then telling your computer, I have this Python thing that is called pandas, but there's also this package called pandas, and it doesn't know which one you're referring to. So when you're naming your actual files, make sure not to name them the names of any packages. I saw that a lot, and it's like a circular dependency error. That's what it'll yell at you about. Okay. Have people been able to work through the first two parts of this? Do we still need a minute? Okay.
First, you have to.
Okay. Does anybody have any ideas on how I can compute the average grade? Yeah. Go ahead. Right. So one way to do this, which is a perfectly valid way, is just to use the NumPy mean function. Like I said, NumPy functions are all super, super compatible with Pandas series objects. And df.grade is a series, so it's like an array. Alternatively, there's also like an inbuilt pandas method if you're just a little bit lazy, like I am a lot of the times. You can just do this, I believe, and that gives you the same exact thing. Either way is valid. They're both the same thing. You're just getting the mean. Does this make sense? Yeah. Okay. Next, we wanted to compute how many people or we wanted to get a data frame of the people that had high grades. And I defined a high grade to be above an 85. Does anybody have any ideas on how to do this part?
Yeah, brackets. Yeah.
Mhm.
Then grades. Then if the grade is greater than 5 out of 7.
Oh my God. Sorry, I can't type. Yeah, perfect. So now we have all the people that have high grades, which are grades above an 85. So all we're doing is we're indexing this data frame at this condition that their grades have to be greater than 85. And note that this is like a process of like row filtering. So there's two main things you can do with pandas. You can filter out columns and you can filter out rows. Filtering out columns means you're just usually getting rid of variables that you don't care about that much. And filtering out rows is just you're getting rid of like individual data points that you don't want in your data set. Sometimes there might be outliers. Sometimes there might be like weird things in your data like nans, which are like you don't have data points there. So the way that you would get rid of those row-wise is by doing this. And let's say you have a column that's useless too, or like that's redundant with another column. You can also just drop those columns. Those are kind of the two filtering things you can do. Yeah. Yeah. So this first DF is just telling us this is the data frame we're working with. The second DF is basically just telling us it's just telling us like what column to look at more than it is like actually accessing like the data frame itself. So you can just think of this as like the first one is telling us what data frame we're looking at. The second phrase in general is telling us what column we're looking at. But you need to make sure that this column is specified by what data frame it's in, just because Pandas is weird about it like that. But that's just generally how that works. Does that make sense? Cool. All right. So the next thing I'm going to talk about is a super useful Pandas functionality that will let you basically, especially if you have lots of data, this is really useful to get like counts of things. So in this question, it's asking us to count how many people per major there are. Obviously, we have kind of a small data frame and there's not that many students and not that many majors, but you could see how this could be useful. Let's say you have a data frame that has like a bunch of different types of like stars and they're all like classified into like stellar types and you want to know what the counts are of all these different stellar types in said galaxy or something like that. That's kind of a very useful application of this. And you could see how that kind of like extends. That's just one example. So the way that you can count how many people per major in this case, I'm gonna like make a new data frame with this information just so we have it. So I'm just gonna call it people per major. And then you can say df at, we're obviously going to use the major column because that's what we're counting. We're counting the number of people per major. And then you do this thing called value counts. And that basically takes care of the functionality of counting. Pretty intuitive. It's counting the number of values in each type in a column. So people per major is going to give me this series that's basically telling me there's 2 math majors, 2 history majors, and 1 physics major in my data frame. Does that make sense? Cool? Yeah. So this one's super useful. You can also like, I'm pretty sure there's different like parameters / optional things you can tag on to value counts to make it even more useful. Sometimes you can like by default get like the means over the counts, or you can get like a mode or things like that. Those are all things you can do, and the documentation has plenty of guidance on how to do that. Plus, I think we're going to go over that in discussion on Wednesday. So TBD, you guys will be able to explore that. And then the last thing, which you talked about a little bit in the earlier example, is let's say that now I want a new column that has information about whether my students passed or failed. And let's say I define a pass as getting a 75 in whatever subject. So this is basically going to be showing you how you can kind of chain things together and make them easier. So first I'm going to show you like a longer way to do this, and then I'm going to show you a shorter way that should be pretty intuitive. But first, let's say we want to filter our grade column. Anyone have any ideas on how we would do that? We did it a little bit above earlier, so you could apply very similar logic. Okay, that's okay. But basically what we can do is take our data frame and we can say df at grade. Oh wait, my bad. Grade is greater than. My God. I'm like extremely low on sleep today. I'm sorry, guys. Okay, so this gave me all the people that are above a 75. However, note that this only gave me the rows that I'm interested in, which that's what we wanted to do, right? In this function, we only get the rows we're interested in. However, what I want to do is create a new column for all the students saying pass / fail, or with like a true or false, like a Boolean value. So the way that I can do that is first, I'm going to create a new column and I'm going to call that pass. And what I can do is set that to whether or not these students have a grade of more than 75. Oh, so socials. So now basically the entire column of grade is being compared against the number 75. If the student's grade is greater than 75, in the pass column, their value is being assigned to true. Otherwise, it's being assigned to false. Does this make sense? Because right now, in the previous examples, we were indexing. We were getting a subset of rows, which is why we were doing df at df. Now we don't want a subset of rows. We just want a new column that contains the information about pass or fail. So we don't need to do the df at df. We just need to have our like conditional statement saying true is when they're above a 75, false is when they're below, and you store that information in a new column. Okay, cool. That is it, I believe, for this lecture. Let me click through these super quick. There should be an engagement to fill out on Gradescope. So yeah, you guys can take the last 5 minutes of class to do that, / ask any questions. All of your final project groups have been assigned, so make sure you check Ed for that information. Yeah, I'll see y'all on Wednesday. Thank you so much.
Okay,
I know I didn't sign up, but I.
sure. Sounds good. You want to co-teach it or you just want to chill out? Okay.
Yeah, I forgot to put my pin, but I shot it there.